Good evening, everyone. I'm Reshma Priya from CSC AML Department C section. Today, our course title is Basic Electrical and Electronics Engineering. I have taken the topic named Describe the Basic Construction and Working Principle of a DC Motor. Coming to the course outcome, there are three course outcomes there. First one, knowledge. It means remembering the course outcome. We have to recall the basic components of a DC motor such as yoke, field poles, armature, commutator and brushes. Coming to the second course outcome, we have to understanding the topic. We have to explain the construction and function of each part of a DC motor in detail. Coming to the third course outcome, application. Apply Fleming's left hand rule to determine the direction of force and rotation of a DC motor. Now introduction. A DC motor is an electrical mechanical device that converts direct current into electrical energy into mechanical energy. It is one of the most important missions in electrical engineering. It works on the interaction between magnetic field and electric field. It is mostly used in industrial drives, electric vehicles, robotics, household appliances, whatnot, etc. Energy conversion. It have two types of energies: input energy, output energy. In input energy, electrical, it means it supplies DC direct current. Output energy means mechanical, it supplies mechanical energy, it in rotationally motion. Conversion process. Electrical energy supplied to armature, magnetic field interaction occurs, mechanical torque is produced. Energy losses, copper losses, mechanical losses, core losses, etc. Basic principle. Based on Lorentz force law, a current carrying conductor in a magnetic field experiences a force. Force depends on magnetic field strength, current and length of the conductor. Formula for the Lorentz force law. F equals to BL sin theta. Fleming's left hand rule. It is used to find direction of force. Three fingers are mutually perpendicular. Thumb finger, forefinger and middle finger. Thumb finger indicates the force. It means motion of the particle. Forefinger indicates the magnetic field. Middle finger indicates the current. It helps determine direction of rotation in DC motor. Main parts of a DC motor. There are so many parts of DC motor: stator, rotor, yoke, field poles, armature, commutator, brushes, shaft and etc. Each part has a specific role in producing rotation. There are 8 types of parts: stator, rotor, yoke, field poles, armature, commutator, brushes, shaft. Each part has a specific role in producing rotation. Coming to the yoke. Yoke is the outer protective covering of the motor. It provides mechanical strength. It also supports for force. It is made up of cast iron, small motors, and steel. Steel is used in large motors. It also acts as a magnetic path. Field poles. Mounted inside the yoke. Types: pole core, pole shoe. Functions: produce magnetic field, spread magnetic flux uniformly, usually made of laminated steel to reduce losses. It is mounted inside the yoke. These are the 3 types: pole cores, pole shoe. Functions: produces magnetic field, spread magnetic flux uniformly, usually made of laminated steel to reduce losses. Field windings. Field windings in copper coils wound around pole cores. When DC current flows from field windings, the magnetic field is generated. There are 2 types of field windings: series winding and shunt winding. Series winding controls strength of magnetic field. Shunt winding in magnetic field is generated. Armature. Armature is the rotating part of the motor. It is made up of laminated iron core. It contains slots for conductors. There are 2 functions for armature. First one, it carries current from chemical energy to electrical energy. It produces torque due to magnetic interaction. Rotating part of the motor made up of laminated iron core and contains slots for conductors. Functions: carries current, produces torque due to magnetic interaction. Armature windings. It conductors placed in armature slots. Types: lap winding, wave winding, connected to commutators. Segments: carry current and experience force. Commutator. Cylindrical structure made up of copper segments insulated by mica. There are 2 functions for commutator: convert AC induced in armature to DC. It reverse current direction. Essential for continuous rotation. Commutator cylindrical structure made up of copper segments. It is insulated by mica. The two functions of the commutator are converts AC induced in armature into reverse current direction. It is essential for continuous rotation. Brushes. The brushes are made up of carbon or graphite. There are two types of metal used for brushes. Carbon is highly reactive and graphite is lowly reactive. It maintains a sliding contact with commutator. Functions are it supplies current to the armature, ensures smooth current flow, wear out over time, need maintenance, etc. Shaft. It is connected to armature. It transfers mechanical energy to load, supported by bearings. It is used to drive machines like fans, pumps. Shaft is connected to armature. It transfers mechanical energy to load. It's supported by bearings. It is used to drive machines like fans, pumps. It is connected to armature and transfers mechanical energy to load and supports by bearings used to drive like fans, pumps, etc. Working principle overview. DC supply is given to field and armature. Magnetic field is created. The current flows in conductors from electrical energy to chemical energy. The force is produced and the armature rotates. This is a summary before detailed explanation. The working principle of DC motor. DC supplies is given to field and armature. Magnetic field is created. Current flows in conductors. Force is produced. Armature rotates. This is a summary before detailed explanation. The detailed working of DC motor. In DC motor, field winding produces magnetic field. Armature conductors carry current. Force act on conductors. This force creates torque. Armature starts rotating. Field winding produces magnetic field. Armature conductors carry current. It force act on conductors like in opposite direction. These forces create torque. The role of commutator in DC motor. In direct current motor, without commutator, the motor would stop after half rotation. So we need continuously commutator for the motor should be rotated. Commutator reverse current every half turn. It keeps torque direction same. It ensures continuous rotation. Back EMF. EMF means electromotive force. When armature rotates, the voltage is induced, called back EMF EB, electron bond theory. It opposes the applied voltage and it controls the armature current. Formula EB equals to P of psi Zn by 60 amperes. The working of torque in DC motor. Torque is a turning force. It is produced due to interaction of field and current. It depends on flux density and armature current. The formula for torque is torque directly proportional to flux and armature current. There are three types of DC motors: series motor, shunt motor, compound motor. In series motor, high starting torque. In shunt motor, we have constant speed. In compound motor, combination of both. These three DC motors are occur morely in DC current. Series motor, shunt motor, compound motor. High starting torque, constant speed, compound motor. Combination of both. Applications of DC motor: electric vehicles, elevators, cranes, fans and blowers, robotics and automation. What the advantages of DC motor are: it is high efficiency, easy speed control, good starting torque, reliable performance. There are many advantages for the DC motor. It has high efficiency and good properties, easy to speed control, good starting torque. It has reliable performance, etc. Disadvantages of the DC motor: it requires some regular maintenance so that we can easily carry DC motor. It brushes wear out, sparking at commutator. It is not suitable for dusty environments. Conclusion: DC motor is widely used machine, works on electromagnetic principle. It converts electrical energy in mechanical energy. In the process of converting electrical energy into mechanical energy, DC motor is widely used machine and works on the electromagnetic principle. It is important in industries and daily life. DC motor is widely used machine. It works on electromagnetic principle. While converts, it converts electrical energy into mechanical energy. By converting this into electrical energy and mechanical, the DC motor produces DC current. It is a widely used machine. It works on electromagnetic principle, converts electrical energy into mechanical energy, important in industry and daily life. Thank you.